Hello guys, my today's topic is evaluate following without using a calculator. Evaluate means find value. When numbers are given to you and you are supposed to find out values, then we say evaluate the following question. Now here the question is evaluate without using a calculator. Whenever this statement is written in the in the examination or in the paper or in your homework or wherever or in the book, you will apply algebraic identities. Remember, whenever you get a valuation of some numbers having some squares, these are not ordinary numbers, have squares on it, but students do it sometimes in a very wrong manners. They just multiply 49 and 49, then 31 and 31. This is not the way. When it is said evaluate following without using a calculator, it means you will use algebraic identities. Now here you have two squares with negative signs, resembles with the formula or with the ID, third ID, difference of two squares. Minus means difference. Minus sign always shows in algebra difference of two things. These are two squares. So we have a term in front of us, difference of two squares. When we have difference of two squares at once, we recall all the identities and ID3 comes into our mind, which is a square minus b square. Resembles with this. If 49 is a and 31 is b, then it is a square minus b square. So how we will open it? We will write down it as a plus b and a minus b. What is a over here? In this given term, a is 49 and b is 31. So we will just write down 49 plus 31 and 49 minus 31 using this right side of the ID3. This is reverse ID. Now, if it is a square and minus b square and resembles with ID3, we will just write down a plus b and a minus b. I am reading it as a plus b and a minus b because I know a is 49 and b is 31. So I will write it down as 49 plus 31 into 49 minus 31. When we will add them up, we will get 80. When we will subtract them, we will get 18. And this is very easy multiplication because we have 0 in first term and this is a friendly number, and whenever you have friendly numbers involved in the terms or in the figures, it would be very easy for you to multiply something. That is why we have used identity over here. Now when you will multiply 80 and 18, which I have shown in the rough column, you will get 1440, and this is the answer of this question. Come to next question. Again the same situation, but the term is in decimal form. We will again use ID3's reversed form. Here a is equal to 6.1 and b is equal to 1.3. Likewise, as we have done in question number 1, we will write down it as a plus b and a minus b because a square minus b square side is given to us. This question resembles with a square minus b square. So this side is given to us and we will go to the other side. Now a plus b is 6.6 plus 1.3 and a minus b is this. We will add up these decimal figures over here in the rough column. I have done addition over here. We will get 7.9. Wherever the decimal is, we will keep the decimal there in addition and subtraction. We won't change the place of decimal in addition and subtraction, but we will change the position accordingly in multiplication. Why? I'll come to this point later. Now first of all, look at addition. 6 plus 3 is 9. Decimal will attain its place and we will write the decimal as it is. Now 6 plus 1 is 7. So 7.9 is the answer of first bracket, and the second bracket after subtraction will give you 5.3. I have written it over here. Now these are two very simple figures. We will write them. There's no use at all calculators because you know the table of 7, 9, 5 and 3 all are small figures. You will write down these two figures in vertical manners over here in rough column. Look at this 7.9. I have shown multiplication, although I am working for grade 7 and 8. There's no need at all to show multiplication, but for your convenience, I always try to put all the rough work in rough column, so it would be easy for you to understand. Now come to 7.9 and 5.3. Here, first of all, ignore that decimals are here. When we multiply, we just ignore. Write down the decimal there as it is, but in your brain, in your mind, ignore them. Suppose that 79 and 53 is with you and we are multiplying them. First of all, we will multiply 3 with 79. Okay, and we will get 3 9s are and 3 7s are, and this is carry, right? 237, 3 9s are 27, 7, 2 carry, and 3 7s are 21 plus 2 is 23. Now next step we will put a cross over here, because this is the rule of the multiplication. When we do multiplication with 2 or 3 numbers, in every step we leave the first figure for this cross. We leave the first figure and write down the cross under it. Now 5 multiplied by 9 and 5 multiplied by 7. 5 multiplied by 9 is 45. 5 I have written over here under 3, and 4 is carry for this step, right? Now 5 7 is 35 plus 4 39, and now we will add up these two lines. We will add them up, these figures, and we will get 4187 without decimal. Now how we will decide? Suppose there is no decimal there. Now how we will decide that where we should put decimal? We will just count in multiplication, only in multiplication we will count the digits on the right side, total digits on the right side of the decimal. In upper figure there is 1 digit on right, and in lower there is 1 digit in right. Totally there are 2 figures, there are 2 numbers on the right side of decimal, so we will leave 2 numbers from here and put the decimal. This is how to place a decimal over here. One more concept is clear to you. So our answer is 41.87. Okay, I hope everything is clear. Now question number 3. Factorize using suitable algebraic identity. Now this is a question with fractional terms in fraction. Now the expression is given to you in fractions. First and second term has square with it. The central term has no square. It means it will be considered as 2ab. Now all the signs are plus. When all signs are plus, all terms in this expression, in any expression, when all terms have plus signs, our mind should go to the ID 1, which is a plus b whole square. I have written over here reversed form because expanded form is given to us. This side is given to us. A square plus 2ab plus b square is given to us. And we will move towards factors, and this is a plus b whole square. So until and unless we write down the given expression, this given expression, algebraic expression, in the form of a square plus 2ab plus b square, until and unless we write down in this form, this expression, we cannot write down, or we cannot close it into this form. We cannot close the given expression like this, a plus b whole square. So factors form, for factors form, first of all we will write down this term as a square and b square and 2ab. Okay, now come to the point. This is expression 16 over 49. It's very clear now. 16 is a square of 4. When we take 4 square, it means 16. 4 multiplied by 4 is 16. When we take 7 square, it means 7 multiplied by 7. It's 49, right? D is already in the form of square. If we write down 16 and 49 as 4 over 7 D whole square, then it would be a square, right? Only D square is not representing a square. Until and unless the fraction given with it will be converted into square, we cannot write down this whole term in the form of a square, and it is very important to write down square terms in the form of this individual whole square, right? Now come to last term first, not middle term. Come to last term first. This is last term. 1 is square, or 1 square means 1. 1 cube means 1. 1 raised to power 4 is 1. So 1 square is always 1. 25 is a square of 5. 5 fives are 25. So we will write down 1 over 25 as 1 square over 5 square, and g is always in the form of square. So in short, we will write down this whole term like this: 1 over 5g whole square. It means this square is working for 1 over 5 as well as for g. So square is a power of all the terms inside the bracket. Now it resembles with b square. B means whatever is written at the place of b, it should be written in the form of a whole individual square. Okay. Now these are two squares. Now we have a and b in the form of 4 over 7d and 1 over 5g. Look at this. A is equal to 4 over 7d, b is equal to 1 over 5g. Now we will just write down 2 along with a and b, and we will split the middle term. And we will write it down in the form of 2ab. Okay. So 2, pick up a from here, write down, pick up b from here, write down, and you can see that you can pick up a from here as well, because this is a square and this is b square. So pick up a from here, pick up b from here, or from here from the rough column, whatever is convenient for you. Pick up a and b and write it down with 2. Now you should check it whether we are getting 8 over 35 dg back or not, right? When you will multiply these two fractions, you will get 4 over 4 ones are 4, 7 fives are 35, and 4 twos are 8. It means 8 over 5 is there, and it is present in the form of 2, 4 over 7, 2 into 4 over 7 into 1 over 5. In this form, 8 over 35 is present. dg is already present over here. These will be also multiplied. It means from this term, which we have written in the form of 2ab, we can get 8 over 35 dg back. And this indicates that we have written, or we have broken the middle term into 2ab accurately. It is very important to check it, and it is very important to check these squares as well, whether we can get this 16 over 49 back or not, whether we can get 1 over 25 back or not. Whenever you write down or you convert some given fraction or number into square, you should once check it down that whether we are getting the original term back or not. Then your process is correct. Okay. Now you are ready to write down this whole expression in the form of factor or in the form of whole square, because you are present with a square plus 2ab plus b square, right? So this is the whole left hand side of ID1. So now we can move towards the right side of ID1, a plus b whole square. Just pick up a, which is 4 over 7d from here or from here. Just pick up b, which is 1 over 5g from here or from here. Write the a and b term over here. Look at the sign with 2ab. What sign is there with 2ab? Plus. Write down plus over here and close it in the form of a square. And these are the two factors of given expression. We have factorized the given question with the help of ID1, because this is the requirement of our question. Factorize using suitable algebraic identity. This was the requirement, and we have fulfilled the requirement by using ID1 and written the answer in the form of a square or in the form of factors. When we have some square on the brackets, it means this whole expression is being multiplied 2 times. It means this whole expression is not a one factor. These are actually two same factors. 4 over 7d plus 1 over 5g into 4 over 7d plus 1 over 5g. We can write down this square like this as well. Okay, so this is a factor form of the given expression. Remember, whenever whole square or whole cube or whole raised to power 4 or 5 or 7, whatever is written on the brackets and something is written inside, it means this expression is in the factors form. And how many factors are there? When the power is 2, this type of two factors of this type are present. When power is 3, it means this type is present in 3, means this expression can be written 3 times. This expression can be multiplied 3 times. I hope it's clear. Whenever you have power 2, it means this whole factor can be written 2 times in multiplication form. If there is power 3, it means this whole factor can be written 3 times in multiplication form. What do you mean by multiplication form? In the form of brackets. We will write down consecutive brackets and one by one we will open it. Next time, in next video, I will show you how you will open it, but there is no need at all. The requirement of the question is factorize, and we have factorized, and this is factor form of the given expression. This topic is still continued, and I will do 2 or 3 more examples on this topic. Then I will wind it up and start the new topic. Now I hope everything is clear. Guys, if my videos are beneficial for you, do like and subscribe so that you may get notification of my upcoming videos. Thank you.